All right, hello. Today we're going to talk about AI applications and we're going to break it down into the different subparts and I'm going to give an overview of the whole thing. This is meant to be useful, helpful to not only business owners who are thinking about AI and what it takes in order to implement something in their business, but also if you're aspiring to get into this industry, what are all the different parts in it, or if you're maybe retooling. So, let me go into my little diagram here, get my pen set up. All right, great. So we have the AI application itself. This is the front end layer. You might have your person or could be another AI agent that is interacting with your application. And this application could be built in React or Django, for example. It doesn't have to be, but it's just an example. And then as we pop this open, we see underneath that it is built on the cloud, perhaps. And it might be in one of these framework infrastructures. So it could be on Azure, Google Cloud, AWS, especially if it's enterprise. And then, but what you have inside of this container is you're going to have an AI engine, which is doing the actual fancy AI things. And then you have a vector database, which is going to be the data in the format that the AI finds native. This is kind of clustering of data around word clouds. You could think of it like that. So dog and cat are both mammals. They're also both pets. A cat and a tiger would be, the cat would be now part of a different Venn diagram circle or a collection of little cluster of words in some kind of a cloud in that other area. So those are kind of vector databases. Then you also have conventional databases. These should not be ignored. They're maybe less fancy these days because people are all talking about AI, but I've seen projects where people try and use vector databases for everything, and that's really not suitable. You're going to get a lot of data problems you're going to get more, for example, hallucinations or false information from your AI if you're not also leveraging conventional databases. So don't forget about that too. And then the actual automation layer itself, or the logic, I have broken down over here. So let me go over on this right side and explain it all. So under the deep learning area, we've got the thing which most people are very familiar with right now, the transformers. That's like ChatGPT. They generate text. They're also called text generators. And but you can also generate images with them. I'm using Midjourney or ChatGPT. And then you do have also some multimodal models as well that can translate from one to the other. You could have image output to text or text to image and so forth, and audio, things like that. All right, so in terms of the training of these systems, so the first kind of training you can do is destructive. So you're going to take this open source model that you're going to bring in, and you're going to do some kind of training to it, which is going to change how it works anymore. You're going to make it only display tabby cats now on your image generator, right? Like that's the only kind of, if I say I want a cat, you only want tabbies. So you might fine tune it so that you kind of teach it that that's what you mean when you say cat. With a LoRa training, it's a similar kind of training, except it's non-destructive. So if you increase your model from, say, ChatGPT 4 to 5 or 5 to 6, you don't have to redo all of the training all over again. You just have, this is more like a modulation or a modifier of the training. And so if you fine tune it, you would be sad because you'd have to start over. But with the LoRa, you're happy because you get to just keep the same LoRa training. There are reasons why you would use one or the other. Most applications that are commercial applications being put into businesses are probably going to be LoRa training if they're going to be needing training. The fine tuning, you need to know that your model is going to be fixed in time. And so, you would not want to be stuck on a particular GPT model unless there was a strong case for why that was important. Other kinds of things that relate here in this machine learning, in this deep learning category would be things like here under the machine learning, this one here, this might be if you had a plot diagram, and then from this plot, you can start to graph out some kind of a trend line. And that is helping you to predict future outcomes, future sales, inventory changes that you need to predict, whatever it might be. But you can also be doing something where you're doing RNN is recurrent neural networks. And so here you're doing a different kind of prediction. And then the other one, this is for image based. This is convolutional neural networks is what it stands for. And so this is more suitable for image prediction, image analysis for machine learning. Under data, when we move on to this section, so there's two parts to it. First, well, you need to know the goals of the application. Let me put this over here because I'm going to reference the goals a few times. But when you're starting to think about your data, you have to think about how you're going to be obtaining the data in order to build the application that you want to build. Is the information in people's heads? Is it stuck in 20 years of emails? Can you synthesize data, create data from scratch, and then have someone review that data and figure out if the data is accurate or what it needs to change? So they then help to review and optimize that data. Can you maybe look at lots of recordings of webinars, or there's all kinds of ways that you can get data, or you can interview people. So you're going to be creating data, and then you also have to think about how the data is being organized. So where do you have things categorized? What kind of categories do you have? And then you also need to be analyzing this data in order to see patterns, or in order to see ways that the data could be better applied and so forth and grouped, or how it's going to be useful for your application, because you eventually want to, you want to be driving this here. This could be also just like a data lake, right? Is also where you might be getting your data sources from. Okay, so under the logic layer here, you're actually building an AI application. Once you know what your goals are, you have like a product manager here, hopefully, right? Maybe that's just the client, maybe that's the vendor who's building it, but someone's going to be responsible for making sure that the application does what it's supposed to be doing and can kind of help guide it. And so with the data in mind and with the goals in mind, and you're going to be figuring out your processes or your logic layer, right? Or both. And from this, you're going to be building some kind of a tree, right? Could be a decision tree or could be a workflow sequence. So that's this whole part. You might be building this in, so some popular places to build it. If you're a small, medium business, you might be using something like N8N. There are many alternatives, of course. If you're a mid-sized or larger business, mid-sized enterprise, you might start looking more at something that is code-based. So you might be using something like LangChain. If you need to have lots of developers collaborating on the same code, and you want to have revisions, and you want to have deployment schedules in different environments and so forth, it's going to be a lot easier to do it code-driven with LangChain than it is to do it with something that is more of a visual builder, a low-code solution like N8N. So keep that in mind when you think about it. But even inside of a large organization, you might still have some smaller deployments of N8N or some low-code solution. For example, within just your marketing team, maybe it's only 3 people, even though you've got like a 20 million, 80 million business in annual revenue. And that's fine, right? Like, this is a time right now where it's better to be making progress and finding the solution and failing 1 or 2 times and then you get it right. That's much better than trying to do it perfectly, taking a long time. Right now is the best time, if there's any, to be doing technical debt in AI because it's so innovative. So just want to throw that out there as another thought. So under the building here is where you're going to be coming up with your contexts, your prompts, and so forth. This is going to be largely informed from your database as well, but it is also its own skill, its own ability that you need to be doing the prompt engineering, the AI instructions or system instructions. You need to think about scalability. So are you wrapping up multiple workflows together? And then how are you interconnecting these different workflows? When I say workflows here, I'm talking about collections of different AI sequences or logic steps, and then all of those might then be grouped into one container, and then that container can be connecting to other systems. Speaking of connections, you've got your API integrations that you need, and MCPs to other systems or services that might be part of that design. You also need to think about the costs of your system. So, for example, if you're optimizing the AI, if you have one large model doing a process, this could be very expensive. But if you break it down into several smaller substeps with small models, each one of those small models might be 1/10 or even less expensive, or 1/20th of the price of the larger model. And so by breaking it down into smaller steps, not only can you increase the accuracy of the answer, but you can also reduce your cost of the operation as well. Performance here, you're thinking about the time that it takes to run an operation or multiple operations. If your system is taking 32 seconds to process, it's probably very slow. So you're probably going to have to optimize that, right? And so again, large models tend to be slower. Several small models can be way faster. So that could be part of your optimization. I recently did a long video on AI testing. You should watch it if you want to go deeper into that. Here, I'm going to just kind of talk about the top level of it, but you need to be thinking about, what is the accuracy you need to be achieving? Is it 99.9999%, or is it 95, or is it 80? What happens when it's wrong? Is 80% good enough? I've seen situations for businesses where actually 80% is fine because it's still saving a tremendous amount of work for the person. You've got an expert reviewing the output, and that expert who's reviewing the output can quickly see when something's wrong. It's getting them 80% of the way there. They only have to work on the last 20, right? So really understanding what kind of quality level is important to achieve is really important. Do you have guardrails to make sure that it's not going off topic? You need to really be thinking not just about your yeses, but your nos, right? So the yes would be, what is the knowledge that we want the bot to talk about? But we also want to make sure that we have very clear boundaries on what we don't want it to talk about. So make sure you're thinking about that. Quality control layer, this would be if you have an AI sequence, let's say, and then you have at the end of it, you have like a little police bot, let's say over here. This is also an AI system, and it's monitoring the output that's coming out of it. And if it sees, it's observing over here. And if it sees that the output here is inappropriate, it can, block the output. It can ask the system to regenerate, or it can just say some kind of a standard output that you might want to code for that. Here we're talking about self-reflection. So if you do have if the system is making an error, how does the system improve? Does it have a step where a human reviews the problems and then has recommendations on how to improve the system to get it better? Or is it self-improving in some way? Does your AI system create a log or some instructions on how it wants to improve its own training data? Do you then have a human review that before applying it? And then do you build enough trust eventually that the AI system can figure out what it's doing wrong? Or let's say if it's doing something that's resulting in something bad, like inventory is not where it should be in your business, and it was dealing with moving inventory between your different warehouses, and it's seeing issues with that, can it self-correct? And have you built enough trust with the system that eventually can do it by itself? A lot of these systems are about trust building, right? At first, you have the human in the loop who's part of that process here to make sure that things are being improved in the right direction. And then eventually, once you build that trust, you can have the human on the loop instead of in the loop, so observing the whole process. And then they don't need to intervene for every single self-update to the system. How are you handling errors, right? When something goes wrong in a particular step, what do you do there? That's the error handling. And then when errors happen or when good things happen, how are you reporting? How are you tracking your ROI results? And then observability, this would be, let's say the system goes down or it's being DOS attacked, how do you get a notification? Or maybe lots of people are suddenly unhappy using this tool, right? They're all over here saying like, I'm upset. And like, how are you getting notified of that? And do you want to get notified right away? That would be the observability. In terms of security and compliance, I have it over here, but I do want to also mention that there's security and compliance for the entire system too, right? And so let's say you want the system to be HIPAA compliant, you're going to have to think about that also on the server level. But there is also security within the application too. So that's something that should not be neglected. And then in terms of there is a relationship to testing too, because if you have certain compliance, the compliance could be related to the output of the system. But of course, there's compliance related to the system itself. So I think I covered the whole thing. I guess the only thing I didn't talk about down here was just I talked about the vector and the conventional, but someone also in DevOps is responsible for that. So I hope this is a good overview of all the different areas. There's a lot of different jobs and scopes of work potential within all these different areas. This should also give you a good oversight of what it takes to really build a sophisticated AI application or system. There are many different things to be thinking about, from the goals to the process to the data, and then how you're building the system, keeping it secure, and then how are you going to be training the models? Where are you going to be storing the model data? Right? Are you doing it in a LoRa, or are you doing it in a vector database, a conventional? Are you only doing it in your instructions, or are you using a mix of all of these systems together? So anyway, if you have questions or if you have comments or things you want me to improve or talk about next, please let me know. I always love hearing your feedback. And yeah, thank you so much for watching my channel. Take care. Bye-bye.